Today we'll be talking about symmetry. Symmetry is when a figure can look the same on one side as it does on the other. Now, because we are studying motion geometry, we're going to be talking about moving figures and seeing if they still have symmetry. So there's two different types of symmetry that we're going to be talking about today. For this lesson, you need to have your textbook open to page 550 and your journal out and labeled 20.3 Symmetry. You're going to be writing down two definitions today. It's okay if you write as I talk to you and explain. It might be helpful for you to draw a couple examples in your journal as well. So I do recommend copying this chart as well as the definition. And then I have one more slide to show you for vocabulary before we jump into our learning together. So a line of symmetry is our first type of symmetry that we're going to be talking about. A line of symmetry is a figure that has a line of symmetry when it can be folded about a line so that its parts match perfectly. So when you think of whether it has a line of symmetry, you want to imagine the figure literally being folded in half, either horizontally or vertically, and seeing if these two pieces can match up perfectly. So, for example, in these letters H, L, Y, O, D, only a few of them have lines of symmetry, and some of them don't have lines of symmetry when they're folded vertically, but they do horizontally, or they do have it vertically, not horizontally, and vice versa. So, the first letter that would be a good idea for you to write down is the letter H, as an example. If we split the letter H in half, do you notice how each piece on either side of that line would line up perfectly? That means that the letter H, that figure, has a line of symmetry. It has a second line of symmetry if we were to split it in half the other way. Again, on the top side and the bottom side, those line up and match perfectly. So the letter H has two lines of symmetry. It can be folded in two ways and all the parts will match up. However, the letter L, if we split that in half horizontally, the top does not match the bottom. That means that this letter does not have a line of symmetry. If we tried it again vertically, we would see as well, or even if we split it here, the top does not match the bottom. The letter L does not have a line of symmetry. You can see from the example, the letter Y, O, and D also have lines of symmetry. However, the letter Y, if we were to split it the other direction, it would not match on the top and the bottom. So it only has that one line of symmetry. The O can be folded in any which way, and it will have a line of symmetry as well. The D, if we split it vertically, it would no longer have a line of symmetry, but it does horizontally. So that's our first vocabulary word of the day, line of symmetry. That involves folding a figure in half and seeing if the pieces match. The next definition that we have today is called rotational symmetry. So for this one, I do want you to copy this definition and also the examples. So if you need more time, make sure to pause the video, but you can keep writing as I'm talking. So rotational symmetry is different than line symmetry because this involves actually moving a figure, not folding it, but moving it around its center point. Now that is really important part to remember. It has to be around its center. And in order for it to have rotational symmetry, it needs to be able to look the same in at least two places. So, for example, we have this little picture of a almost like cross/star. For the purpose of your notes, it might be helpful to just make it as a cross. Now, I'm going to color the top part of it red so that you just so you can see where my starting point is. So if I were to rotate this on its center, so I drew a dot in its center. If I were to rotate this around, and now this is where yesterday's lesson has come in handy. What kind of a turn is that I just drew? That's a quarter turn. How much is a quarter turn worth? A quarter turn is equal to 90 degrees. So if I were to rotate this a quarter turn or 90 degrees, and I'm doing it clockwise, so we're going to have lots of layers from yesterday's lesson. I'm doing a quarter turn clockwise. This is what it would look like now. With the little red tip to show you that's where we started. Let me redraw that. That's a little messy. So now that part that used to be at the top is now on the side, but do you see how it still looks like a plus sign? So I can rotate this around all the way around and it will still have symmetry. So this means it has rotational symmetry because it can look the same in at least two places as long as you rotate it around its center. So make sure if you don't have this written down yet, that you get it written down, at least the example that I drew here, as well as the definition at the top. Pause the video if you need more time. All right, we're going to talk about a couple examples of symmetry in the figure. So it either is going to be line symmetry, rotational symmetry, or both. Okay, so this example is coming from your textbook. Let's take a look at this building. This building is actually in San Francisco. It's the Trans-America Pyramid Building. And if you notice that blue line here at the top, if we were to split that building vertically in half, so that would be making it fold on a line. So that would be line symmetry. Do you notice it's the same on both sides of that line? All the way from the tippy top to the bottom, it's the same. So that means it has line symmetry. Let's take a look at the example of a letter Z. We can actually draw this in your notes as another example. Let's draw a big letter Z. So if we take the Z and we split it in half, this is making it have a line through it. Now, at first glance, it does not look like those pieces are the same. What it looks like is it looks like we have this. Now, if we were to actually rotate the pieces around, do you see how this side matches up with that side across it, and this side matches up with the other side? So if we were to split it and turn it, it would match. Now, that is not a line of symmetry because a line of symmetry doesn't talk about rotating it around. This is rotational symmetry. So let me draw this for you again. So this is not line symmetry. I just write not line sim for short. For the letter Z, I'll draw that again. I'll draw out a regular one. And now this time I'm going to rotate it 180 degrees. So I'm going to rotate it across a line. I'm going to rotate it 180 degrees. Now, to do that, I'm going to, because I can do this, I'm going to actually select my figure. I'm going to physically rotate it 180 degrees, which would be half of a circle. So I want you to imagine, let me draw that line for you again so you can see that. I'm going to take it, I'm going to do half of a circle rotation. That would be 180 degrees. Watch now. When I flip it, what does it still look like? What letter does that still look like? It still looks like a Z. So some letters, other figures can be rotated to still look the same when the flipping is done as it did before. So that's what symmetry is. It looks the same on one side as it does on the other, or when you move it, it looks the same as it was in its original position. So let's take a look at number one. Number one, we have this picture here, a hexagon. So we're going to draw that out. We're going to draw out that hexagon the best we can. It is facing with a point up. Okay. And it's got a dotted line through the center. So number 1 says a line of symmetry is shown in the figure. Trace the figure on dot paper and draw 3 other lines of symmetry. So we don't have dot paper. That's okay. We're going to just sketch it out. So that's one line of symmetry. Do you see how it's the same on this side as it is on the other side? When we split it that way, we end up with 2 trapezoids, which are both the same. Let's go ahead and draw another hexagon. Same figure. We're just going to split it a different way. So we already split it up. Let's see if we can split it across. Do you see we have the same thing? We do. We have now a pentagon. We have on the top, we have a 5-sided figure that's equal, and on the bottom, we also have a 5-sided figure that's equal. Okay, we need 2 more lines of symmetry. Go ahead and draw another hexagon the best you can. All right, what if, let's try splitting it at a diagonal. Wow, really cool. When I split it at a diagonal, I end up with a similar picture as the first one, just tilted a little bit, but still a line of symmetry. It's the same on this side as it is on the other side. Okay, one more. Go ahead and draw one more hexagon. And let's try splitting it diagonal another way. And look, again, we end up with the same. My hexagon was a little bit messy that time, so it doesn't look quite right. But it is the same on this side as it is on the other side. So lots of different ways for that figure that we could draw lines of symmetry. Now I want you to notice, each time I do that, I'm splitting it in half. Let me show you an example of why we want to do that when we're drawing lines of symmetry. If I split it in another way, like let's say I draw my line like that. Although I've split it across the figure, I'm not splitting it evenly. And with symmetry, we want things to be even and equal. So you're going to want to make sure that wherever your line is, that you come at it across the middle of the figure, whether it's going across or up and down or diagonal. You want to make sure whichever way you do it, that you're doing it evenly, splitting the figure in half. All right, we're going to take a look at some examples of real life and see whether we can see any line symmetry, rotational symmetry, or both. So number 2, we have a picture of a butterfly. Let's just sketch that out for ourselves. It's okay if it's not super fancy, just do your best. Okay, so looking at this figure, I can imagine splitting this butterfly straight down the middle, and I see it's the same on the left as it is on the right. I see 2 wings on the left, 2 wings on the right, 1 antenna on the left, 1 antenna on the right, half the body on the left, half the body on the right. So this would be line symmetry. Now, looking at it, if I were to split it the other way in half, I'll use a different color so you're able to see. If I'm able to split it in half across, that's not going to be the same. The top has antenna, the bottom doesn't. In the actual picture, they have these fancy little extra parts to their wings there. So it only has 1 line of symmetry, but it does have a line of symmetry. Now, because of these extra details and the different shapes of the wings and whatnot, if we were to turn this butterfly with rotational symmetry, it would not be the same figure. It would not be the same in multiple positions. So it only has line symmetry. Let's take a look at number 3. Number 3 is a wagon wheel. I'm going to do my best to just sketch this out the best I can. All right. So looking at this wagon wheel, I can tell, yes, definitely it has a line of symmetry. If I were to split it just right down that center spoke, I'm going to have the same on both sides. So it does have line symmetry. Let's see if it has rotational symmetry. Well, this one should be easy. We watch wheels rotate around every time we leave our house and look outside at cars driving by. The wheels look the same even as the car is moving. The car's not bouncing up and down. So a wagon wouldn't be doing that either. It looks the same as it spins and moves. If we rotate this wheel, it's going to look the same. I drew a dot for the starting point. I didn't pick up my pen, so hopefully it will allow me to do that. So if I move this clockwise a quarter turn, you notice how it looks the same? And what if I kept going a full 180 turn? It also looks the same. And a 270-degree turn looks the same as well. So a wheel can spin round and round and it's going to look the same no matter what. So this also has rotational symmetry. Let's take a look at number 4. We have a ladybug. Again, I'm going to sketch this out just briefly so that you can do it in your notes as well. It's got 6 legs, 3 on each side, split in the middle. Now, it does have some odd spots. It does have some odd spots. So, looking at this ladybug, I'm going to say let's ignore the pattern and let's just look at the shape, okay? So if we were if we were including the pattern, we would have to say that it has neither because the dots are different, but let's just look at the shape of the ladybug. If we were to split it across vertically, we would end up with a ladybug that has a shell on the left, a shell on the right, 3 legs on the left, 3 on the right, 1 antenna on the left, 1 on the right. So that means it has line symmetry. However, similar to the butterfly, it's not going to have rotational symmetry because it has different parts. The bottom is different than the top. It's not uniform all the way around. So it just has line symmetry. All right, now taking a look at the penny. This time, I would like us to include the pattern we see on the penny. So looking at the penny, picture of Abraham Lincoln. Now, if it was just a circle, that would be one thing. I'm going to just draw a little sketch of a man on there. If it was just a circle, it would have line symmetry and rotational symmetry, but I want you to imagine splitting a penny in half. This side has the back of Abe Lincoln's head while the other side has his face. So that's not the same. And that's going to be true of wherever we split it, as well as if we rotate it. The pattern on it causes it not to have a line of symmetry or a rotational symmetry. So this would have neither. Now, going back to the ladybug before, remember that would also have neither if we were including the pattern. So typically, we should consider the pattern. So we'll keep that in mind as we continue practicing. All right, these ones are a little bit easier for us. They have a little bit simpler patterns. So again, we're going to continue talking about whether they have line symmetry, rotational symmetry, both, or neither. So since you've seen me start to do some of these, I'd actually like you to begin doing these yourself. And pause the video, unpause when you're done, and I'll show you the answers. All right, so hopefully you solve these on your own. Let's talk about the answers. So number 7, the heart. That has line symmetry. If we split it right down like that, it would be fine. If we do it the other way, that is not true. It does not have rotational symmetry. Let's take a look at number 8. Number 8 has both. You could split it down the middle. We had an example like that in our notes. We also could rotate this around, and that would have rotational symmetry also. This pinwheel fan, this has rotational symmetry for sure. Let's see if it has line symmetry, though. I don't think it does. If I split this right down, well, actually, it does. Yeah, depending on if you're really straight. So we'll say that number 9 could have both as well. It could spin and be the same on another side. Don't worry about the colors though. The colors would make it have neither. And number 10, looking at this figure, I cannot tell if that is a cookie or a sand dollar or what. However, I see that the patterns are a little bit unnatural, and even the shape of this bottom part is different than the top. So this is going to have neither. It's not a perfect circle, so that means as we turn it around, it's not going to look the same. And the lines running across it this way and on the other side are not even. So number 10 should have neither. All right, let's take a look at 11 through 14. So we're going to continue talking about lines of symmetry. We'll have a chance to draw some lines of symmetry. So again, we're going to sketch these out the very best we can. Number 11, go ahead and draw 2 parallel lines, and then 2 lines intersecting in a triangle, and then same thing on the back side of it. Okay, so looking at the lines of symmetry for this figure, I see right off the bat that we can definitely split it down the middle. I'm imagining splitting it down vertically, and that wouldn't be the same on both sides. So that is the only line of symmetry that I'm seeing right now. I'm wondering if we try to split it. I'm going to draw this again. I have an idea. So sometimes with geometry, you just got to visualize it and see. I'm not even sure if this idea will work until I've tried it. I'm going to test it in another color. I'm wondering if I split it diagonally. Oh no, that wouldn't be the same because of the tip there. Okay, so no, that does not work. So if you need to try something out and then change your mind, that's totally fine too. I have to do that for sure sometimes. All right, number 12, drawing a right triangle. Seeing if we can find a line of symmetry. Now I can tell if I draw and try to split this in half, that does not work. If I try to split it in half diagonally, that also does not work. That makes different triangles. Let me see if I can split it from another corner. Let's split it this way. Oh, hold on, back it up. Okay, now mine is not perfect, but if I do it on this one, the pieces do look like they are the same. I fold that over, it's going to match perfectly. So that can be our line of symmetry. Let's take a look at number 13. You know what? We're actually going to skip 13 because we've done that twice now. Let's do number 14. Okay, number 14. Draw the top and the bottom of a rectangle. And then start drawing down, but then don't go all the way, go out. And then back down, and then in, and then down to meet up. So again, on the other side, go down, and then out, and then down, back in, and down. Now, again, it's not perfect. I'm not using a ruler, so that's okay. Now, if I were to draw straight down, I do see that the sides would match. So that does have one line of symmetry there. I believe I can also draw across. Yes, and that matches as well. Now, can I go diagonal? Yeah, that works too. Diagonal works both ways. For this next section, we're going to draw figures that have a certain amount of line symmetry possibilities. Number 15 says, draw a figure with 0 lines of symmetry. So if it has 0 lines of symmetry, it needs to be like a random figure that doesn't have mirroring sides. So I'm going to just draw a random shape. So go ahead and draw whatever you'd like. It just needs to make sure that it can't be mirrored on the other side. Number 16 says, draw a figure that has only 1 line of symmetry. So This should be something that you can't split vertically and horizontally. It should just be one or the other. The first thing that comes to my mind when I think of one line of symmetry is a triangle, because it could only be split up and down. I can't split it through the middle. Okay, let's try number 17 now. Number 17 asks for 2 lines of symmetry. So let's draw a figure such as a rectangle. There's lots of different shapes that have at least 2 lines of symmetry. A rectangle is just one example of them. It can be split vertically. It can also be split horizontally. 2 lines of symmetry. And number 18, draw a figure that has rotational symmetry. So this should be anything that can be rotated and turned. The example I gave you at the beginning of the lesson was a cross. We also could do a circle, would have rotational symmetry. Also a hexagon, anything that is the same on all sides. An octagon, a hexagon, any of those things would be good examples that would be able to be rotated. Now, it's okay if your drawing is not perfect, as mine are not either. All right. For numbers 19 through 22, we're going to use these figures over here to answer the question. Number 19 asks, which figure appears to have 6 lines of symmetry? So before we get in there, let's take a look and see. So first, I see kind of a square shape. I know that is not going to have 6 lines of symmetry. It'll have the one across, and well, let's see. It'll have one that way, one the other way. That's 2, 3 diagonal, 4 diagonal the other way. A only has 4 lines of symmetry. How about B? Well, B, I can split vertically. I can split, how else can I split it? I can only split it vertically. But I could do it vertically from each point. No, I can't do it from that point. Okay, so that only has 1 line of symmetry for this one. So it's not B. Let's take a look at letter C next. So I notice I can definitely split it between each of the flower petals. So if I do that, that's 3 lines of symmetry. I can also split it across the flower petals as well, which will give me another 3. So 3 and 3 is 6. So the correct answer for which one can have 6 lines of symmetry is the letter C. At first glance, I honestly thought that it was going to be D, but here's why it's not. D can only be split a lot more. It can be split 8 times. Similar to the flower petal, it can be split at each point and in between each point. But the correct answer is C. Number 20. Which figure does not appear to have 180-degree rotational symmetry? So that means that if we were to take it and rotate it on a line, so halfway around a circle, so basically flipping it upside down. So which one, if we flipped it upside down, would not be able to be symmetrical? So I'm going to draw out those shapes for you and flip them around. So here's A. A is just like a diamond. I'm flipping it, and it looks, as I do that, just like a diamond all the way around. So A, it definitely can be rotated 180 degrees. So it's not A. Let's take a look at B. I'm going to flip it from the top 180 degrees to the bottom, and we can see that the straight line ends up on the top. So B, that didn't take long, but B was our correct answer for number 20. It does not appear to have a 180 degree rotational symmetry because it's not equal on all sides. The one part is pointed, the other part is flat. So the correct answer for number 20 is B. Number 21, which figures appear to have symmetry when they are turned 90 degrees, 180 degrees, 270 degrees, and 360 degrees? So it's asking which one is going to be the same, whether you turn it a quarter turn, a half turn, 3/4 turn, or a full turn around a circle. So looking at our figures, I can tell we already know it's not going to be B, because B we discovered couldn't even do the 180. So let's take a look at this diamond, because I have it drawn. So we know it can go, let's put it back at the top. So if we flip it 90 degrees, it's still a diamond. 180 degrees, still a diamond. 270 degrees, still a diamond. And back up to 360 degrees, still a diamond. So far A is a good choice. Let's see if C or D could also do that. So C, I can tell it's the same all the way around. Its base is like a circle. So I know if I turn that, it's just going to continue 90 degrees, 180, 270, and 360. So C will also have that same symmetry. And then looking at D, the star, same thing. It has points all the way around it. It's an even number of points as well. So D will also be able to be turned in all of those ways as well. All right, number 22 asks which figure appears to have the most lines of symmetry. We already figured that out when we were solving number 19. The correct answer is D, because it has 8 points. It can have lines of symmetry at the points and in between the points, which makes a total of 8. All right, you guys, now's your turn to do your work yourself. We're working on 21.3 PW. We're solving all of it. Make sure that you have this answer key pulled up and that you come back to it later for your answers after you complete your work. So we have a Zoom meeting today at 11 a.m. Come ready with questions, and I can't wait to see you.